Good afternoon. I hope I am audible to everyone. It has been a long day, in fact, a lot of interesting sessions on technology, sharing of experiences, pretty insightful to me. I'm sure it must have been to you as well. See, I'll be talking on intelligent twins. They are called intelligent twins or digital twins or smart twins. There is not much of a difference between these three terms, but I'll try to sort of explain through my presentation what are these and how they are relevant today. People talked about AI bringing in revolution. Some talked about metaverse or quantum computing, all these new technologies. But can these technologies only on its own bring the revolution? The answer is no. There has to be a collaboration of technologies which have to come together and bring in this revolution. So intelligent twin or digital twin is all about collaborating all these technologies. My name is, I don't want to reintroduce myself. My name is Sunil Peer. I'm part of, I'm part of Huawei. I'm based out in Dubai. I handle the digital transformation projects. So I just wanted to share with you my experiences, because you guys will come out of the college and you will start your professional experiences. My experiences has been working with customers in their digital transformation journey. And there are challenges. Things are not as smooth as they seem to be. There are some logics one need to understand. We need to understand the technology architectures. We need to understand how the technology has evolved. So I've tried to sum it up everything in a short presentation that we have today, so that I'm able to communicate it to you, and the takeoff will be that when you leave out of the room, you know what a digital twin is. See, let me go back, in fact, maybe 3 to 4 decades. If we see, say around 40 odd years back, technology started getting innovated, in fact. We had the mainframes, which was, they used to be in one particular IT room, and in that IT room you had to take out your shoes and get into that room. Outside that room, there was nothing else. All the processing of the data used to be happening in that particular IT room. And the term IT came into existence pretty late. It used to be called EDP, Electronic Data Processing Room, which was there. But there have been 3 major innovations that have happened in IT. The 3 major innovations are when the x86 processors got launched, the end-user computing became popular. You had the workplace automation happening, because everything in the offices was in manual. You had no desktops, no laptops. So when the x86 processors came, you started automating the workforce, and the automation picked up across industries. This was the first innovation. Second was the network, because you now had the automation at the end user level or an edge level. You had to have the connectivity, because I remember before 1990, you had ARCnet LANs. And these ARCnet LANs were 4 kbps from a speed perspective. So you can imagine the amount of communication capability these ARCnet LANs had. The Ethernet network came into existence. Now, Ethernet network changed the complete paradigm of connectivity. You got the new standards, they were announced. You got the better speeds of the network possible. It started with 10 Mbps, and then it started gaining faster speeds. Today you have speed available in Gbps. And then the AI. AI is recent. There are a lot of things that have been done, the small pointed solutions as far as AI is concerned, but still the potential of AI is unused. 80% of the potential is still unused, because there's a lot of work which needs to be done pre-AI, pre-implementing AI, and post-implementing AI. I'll talk about that. Now we talk about Moore's law, Metcalfe's law. I'm sure you must have read that, these laws. Moore's is where the processor speed will keep changing higher and higher, and there will not be any increase as far the price is concerned. The commercial increase will not be there, but you will get higher processor at the same rates. Metcalfe's law is that you will have a connected world. You will connect different point-to-point connections will be there, and the cellular network will grow. It will grow across the globe. And AI is anyways getting implemented in different use cases. Now, let me give an example. Now, before giving this example, I just wanted to share some statistics. The global research organizations are predicting that by 2025, which is 20 months ahead, we will have 100 plus billion devices connected across the globe. So imagine you have so many devices connected. These connecting devices will have the capability of sensing as well. So that means we will have a refrigerator which will know what is inside it, and it will send a message to us that this is the grocery shopping list which needs to be bought, because it will know what is inside it. When we will pass through a restaurant, our phone will automatically grab the vouchers and the schemes of that restaurant which are running there, and we'll come to know that, okay, what are the schemes there. We can have online parking. So we can book the parking online and sort of go and put our cars there. Or we will have, while we are driving a car, the car will automatically capture the driving habits. It will analyze those driving habits. It can share those with the insurance companies, and those can fix up the premiums of the cars every year. So all these possibilities are in a beta mode right now, and they are getting implemented in the next 15 to 18 months. Now, I just wanted to share with you a very simple example to understand. I just wanted to first tell you about the components or elements of digital twin, and then I'll get into the digital twin. Now, these are a few of the elements of digital twin. You have the data and models. Like, for example, most of us use smartphones, or we have those fit bands or those healthcare gadgets which are there. Now, these gadgets capture our personal data. Like, for example, it shows the heartbeats, it shows when we are walking or we are running or we are sleeping. So these are the details it displays. Now, for example, when it captures the data, this data gets captured through sensors, because there are a lot of sensors on this gadget. And these sensors, there are also models within this gadget. So you have the sensors, you have the models. These are pre-defined or pre-integrated inference models which are there. Now these sensors send the data to the models because they work together. The sensors, which is the data, which capture the data, and the models which are there, they work together. The togetherness of these, the data and models, is called assimilation. So data assimilation is nothing but capturing the new data and working it with the models. Now, these models are developed keeping in mind the application they relate to. Like, for example, in a fit band, you have two types of models generally which are there. One is the machine learning operational model, which tells us when we walk or run or sleep, the activity part. Second is the physiological model, which talks about the physics of our body. Like, for example, the cardiac system, the beats within the heart. So all that is from the physiological model. So both these models work together. And the best part in this is that it's a personalized data. It's not a population data. It's a personal data which keeps changing, which keeps redeploying the models, and these models keep evaluating, actually, evolving actually. So you have new data coming through sensors, you have these data re-evaluating, re-evolving these models. So this personalization and re-evolving of data does not happen only in basically these gadgets. It happens across the industries. Then you have the fourth element, which is prediction. So these models have the capability to predict. Like for example, it says that, okay, you have 96 heartbeats per minute, so just you have to relax or you have to sit. It'll not only predict, but it'll give suggestions also. It'll give recommendations as well. And then based on those recommendations, we can take decision. So this is an evolving model, and this is the data which is getting captured on day-to-day basis. It is the new data. It's not the static data. It's the dynamic data. Same thing happens in other industries. I have taken an example of aircraft engineering because of a reason which I will tell you later. Now in aircraft engineering also, you have a similar concept. I just wanted to make you understand how digital twins work. In aircraft, you have a lot of IoT devices which are put in, because aircraft has different components. And these IoT devices are of different nature. You have the industrial IoT devices, smart IoT devices, light, semi-smart devices, which are deployed across the aircraft. Now, these devices they are intelligent devices, they capture the data. And and you have the models as well. Now here the models are different than you use in a Fitband, because here you have the engineering models, which are based on mathematical and statistical model. And you have the laws of physics and laws of physics and the equations which get applied here. And these models have the capability of predicting well. Now the data which is captured by these devices, sensors, is obviously, it works with the models. The data and models work together, which is called data assimilation, which I said. And then based on that, there are predictions which are made. Like for example, the structure of an aircraft, how it will run on a runway, or when it will take off, how will the structure adapt to that? Or for that matter, while it is basically landing, or when it is going through a rough weather, how it is going to be performing, or if there is a wing in an aircraft which is damaged, what should the aircraft be doing? And it's only for this data modeling and this data prediction which is happening. It is for that particular individual aircraft, the personalized data of that particular aircraft. Now imagine if there is a fleet of aircrafts. We have, say, 100 aircrafts. So every aircraft needs a twin. So the model which is there, which gives the prediction, which is personalized, which is dynamic, because the data of the aircraft also changes. Today, aircraft will have, say, X data. After 3 years or 4 years, it will not have the same state. So the data will change, and the models will also get evolved. The model which is there, twin model which is there of that aircraft, which is personalized and which is evolving, is called a digital twin. So like for example, you have a twin of an aircraft where you are able to map most of the components of the aircraft. You are able to predict well. You are able to test the aircraft before actually it gets into the trial in air. You are able to sort of have the learnings, the challenges, the risks, the risk mitigation strategies before it is actually, before it comes into action. Now, the reason I took the aircraft engineering example is the concept of digital twin was, it came into existence 60 years back when US was launching the NASA program. They were sending the spaceships to NASA. There was one, under Apollo program, there was one Apollo 13 which got damaged, and it was in space and it had a lot of astronauts in it. they just wanted to sort of sort out the issue. What they did is they created a model, which was obviously on Earth, and they captured the data from the aircraft which was in space, and they started feeding that data through the sensors into the model. And they tried to sort of make the predictions, derive the decisions to make sure that the astronauts can sort of be saved and they can land safely. There is a movie on this, Apollo 13, and it's a pretty popular movie. It captures the complete episode. The term was not used at that point of time. The term came into existence only after 2000. It was in 2002. It was given a name as digital twin. We can call it a replica of a physical object, which has the personalized and evolving model. Now, can we create a digital twin for a complete aircraft? The answer is no, because you need a lot of data, you need a lot of sensors. Sensors technology has moved ahead. It has significantly progressed if we see in the last 1 decade. Now, what we are saying is that we are heading to a futuristic world where the technologies, 5 technologies, which is AI application obviously based on the industry it belongs to, compute, we have quantum computing right now, which is getting tested because there are a lot of application and algorithm testing which is happening. Connectivity, you have 5G, 5.5G is under trial, which is going to be launched soon. And you have cloud, because cloud becomes the basic platform. The reason we have been able to do more and more projects is because we have been able to offer all these technologies on cloud as an intelligent twin. So that ends my presentation because the time is up. Thank you very much. Thank you.